Alright, I built the second Huff and Puff circuit, and I want to tell you, these things can be a little flaky. This one here, you can only set it to be within 50 hertz, okay, the lock points. This one, you can go down to 24. I want to tell you, if you bump it, okay, sometimes if you go near it, so you're going to really have to notice it jumped by 50, okay? Those are locking points. And I pulled my hair out because I wired the one that's in here exactly like this. I laid the parts out exactly the same way. Wires ran exactly the same way, same length, same batch of chips in all cases, okay? And I didn't know what was going on. I thought maybe it was the 60 megahertz oscillator module, and here it is here. One of them was actually bad that I bought. That's what I was thinking it was, but it wasn't. So it's just they're a bit flaky. You got to have really good power supplies on, which I don't have really good power supplies on. In other words, short wires. Right now I have long wires. There's a lot involved, but is there a reward? Okay, so I have an oscillator. If I build it into a box correctly, I could use it for a direct conversion radio. I don't know if you've ever built a direct conversion radio, but on a direct conversion radio, the oscillator is very close to the incoming signal, and it beats it and makes it audio, whether it's code, sideband. The AM sounds terrible on one. It's similar to one of them SSD units. But anyway, software-defined radio, SDR radios. But I just wanted to show you, I did put another week in of running in circles and doing scientific method. And a lot of it is, it's not a project you can get results right away with. You're going to have to stay with it and iron out the bugs. And there are people that I guarantee put them together, 1, 2, 3, and theirs didn't do anything weird. It's like my first board. The first board I did of this batch, okay, within 20 hertz. And then the same identical circuit in the same fixture. And see, it just jumped up. And that's because I put a vibration to the desk. There, it does it again. Any kind of vibration gets into this tuning cap. And then I notice if I turn the air conditioner off, this piece of aluminum flexes and changes, okay? But any kind of vibration, so you got to really have it electrically and physically. Let me shut it off. Physically and electrically sound, okay? It's not a circuit that's can be ridden on a rocket ship and stay locked, okay? It's flaky at best, but it was interesting because I wanted to see what attempts were made to keep an oscillator on frequency back before those new units, and I can't remember the letters. Everything's got 3 letters, but in other words, you buy these modules on eBay, and I showed you in the last video how many parts you need, power supplies, and I mean, by the time you get done, the oscillator section and power supply for that oscillator and readout and pad, data entry pad, and the little data switch. By the time you get all that, that's actually more than the radio. And I was saying to myself, there had to be something in the interim, and it was never really perfected. Okay, that's why they went to the modules. I understand why, but I kept saying somewhere along the line, somebody got a radio really accurate. They did. Some of the Collins radios, they used a really big piece of ferrite piston on the oscillator. And how I noticed, I actually fixed a Collins radio for someone. It saw action on a ship, and the wire for one of the films of the tube, the ground side, came up through the lug and was never soldered. So somewhere along the line, someone stuck a piece of cardboard in alongside the tube to make it make contact. I took the whole radio apart to see what the problem was. It turned out it was never soldered. Okay, and I soldered, I fixed that. The Collins had a bad tube, And then he had given me paperwork. The guy that gave it to me to repair. And over the years, that big hunk of ferrite material shrinks. And when it shrinks, it becomes more dense, and the inductance of the oscillator goes down, and the frequency dial goes off. So you have to take someone figured out, you take a couple turns of wire off the oscillator, and it comes right back in, because you can't fix this giant chunk of ferrite. Who's going to make something like that, you know? But someone said you just take, I think it was 3 turns, and it was a big article, and the guy had a lot of pictures, you know, be careful, don't do this, don't do that. But that sucker, when I compared it to my R71A, it was dead on, it was really good. But that was back in the day before I had a frequency counter. See, when a radio is wide enough, the oscillator drifting up and back, you don't notice anything. But if you're copying CW with a very narrow filter, you'll notice it, and it'll make you nuts. You got to keep adjusting the radio. But that's how it was back in the day, and nobody seemed to complain. But now everything's digital. You know, very few people do code. They just get on there. It's CB radio. That's why I make fun of it, because I listen to what the people say at night, and it's not like it used to be. There were people on there that were building things, that were repairing things. They're almost never on there now. They have a guy, you have a group of guys talking, and they all get Bob or Bill to come over to the house and put their antennas up, because none of them know what the hell they're doing anymore. And I feel that's sad, because that was part of the being a ham operator in those days, is you at least attempt to put the antenna out together, and then you call Bob or Bill. Okay, but it seems to be everything's changed. You know, I have kids in my neighborhood here. They don't work, and the parents don't know what to do with them. They don't have to mow the lawn. They don't have to go to the store and get anything. Once in a while, they may drive the parents somewhere if the parents' car doesn't work, or something like that. But I've seen so much change, and people my age will say, "Oh, the good old days," and then the articles say every generation thinks theirs were the good old days. Well, I'm going to tell you what we're going through right now in this country. If that's going to be somebody's good old days, I feel sorry for them. You know, that's where I'm at now. But I stayed with this thing to get a better understanding of it. It probably would work the best if it was laid out on a circuit board with a ground plane, but I'm not going that far. I just wanted to see this thing work, and I got to buy one of these from eBay and see that it actually is pretty good if you get a good one. Okay, you know, that's 1 hertz, and you, like I said, you know, a couple times I picked this thing up and set it down like that, and this thing jumped on me because any kind of vibration into this, because this needs to be done a little bit better mechanically on a stiffer frame, and yeah, those days, you know, to bend a piece of steel or a thicker piece of aluminum, I have a brake and it won't do. It barely does this thickness, you know. But I put a lot of time into this, and then when you finally get it working and you really understand it, it's not that hard. But then, like I said, I have one circuit board that'll lock at 20 hertz, stay within a lock point of 20 hertz, and one that does a lock point of 50, and they're identically wired. All the ICs, all the parts are from the same batches. Hilarious stuff. But I've seen that before in working in a company. If you fix certain units, you get better ones in the batch, and you can change the parts till the cows come home. And there's no modification. It's just that you got all the best parts, and the parts all are in the zone. Let's put it the synergy, and the circuit board just works better than other ones. You know, you have a bunch of radios, and everybody's got the same radio, and one person's got one that sounds better than everybody else's. That's because the speaker is probably built better. It's the same speaker, same materials, but the centering on the magnet, it just hit the point. Okay, hit the synergy, the sweet spot, and you got the same people. They got the same radio, and one guy's got one that just sounds better than everybody else's. And as a repairman, you can go through it, and you can do part swaps. And you might find that in some cases the speakers are kind of chintzy. And if you're really lucky, when you open it up, you notice right away the person has a different brand of speaker in the same radio. Okay, and then as they produce the radio, they switched the manufacturer for the speakers, and you notice right away. And then that'll get out. That'll get out. It's like the GE Super Radio. There's certain serial numbers that are better than other ones. You can get like really into this stuff, you know, and all the super radios have all the same parts, but somewhere along the line, one of the parts got dummied up a little bit, and the newer ones don't work as good as the older ones, and you see it. But this was funny. It happened to me, and I used to divide by 10 to get the 20, and then when I went and did the second one, I used the same wiring, the same